All right, it looks like we have a few more folks joining in with us here. Thank you all for being here at this next presentation of the day. Here with me, I have Dror Helper. He's a Senior Microsoft Specialist Solutions Architect with AWS. And Dror, whenever you're ready, you can go ahead and begin your presentation and join us on camera.
Hi. Hello, everyone. In this session, we're going to talk about how to incrementally modernize your ASP.NET, probably monolith in the cloud. Because this whole day is about modernization, and I wanted to talk about how to use the different tools and the practices that will help you modernize your existing code in a way that it will run in a more cloud native and a better way. So let's talk about the monolithic architecture. There's nothing bad about the monolithic architecture. There's nothing bad about having a monolith. In fact, if you have developed ASP.NET in the past, you probably have created one code base that has everything from the backend to the front end, probably using MVC. And that is a good way to get started really quick. Have a very simple code base that you can easily deploy and easily test end to end. And everything looks fine until a few months or a few years go by and your code base start to grow, start to get more and more complex. And as the size and complexity grows, it's become increasingly hard to improve your code. It's hard to add new features. It's hard to fix bugs. And all of that because it's hard to know where one functionality begins and another functionality ends. And your developers waste more and more time trying to understand or figure out how certain things need to be inside your application because you have only one code base with no clear boundaries inside of it. And the other thing that happens is that it becomes, takes more and more time to start your application. You have more things that need to initialize. You use more memory. You have a bigger footprint altogether, and a monolith start time starts to be a big hindrance to your development efforts. And it's not just that. It's starting your servers takes a long time, either in production or in development. Just something that wastes a big chunk of your day. And the other problem is that when all your functionality is in the same place, you can't scale individual components. And when you can't scale individual components, you have a problem because if one component needs more CPU, your whole application needs more CPU. If one component have a different memory or other resource requirements, you need to scale your whole code base together. You need to either use more powerful infrastructure or you need to duplicate your code base across multiple services, multiple servers, and you can scale a single component. And then the next thing that happens is that usually your deployments start to be further and further apart because every single time you need to fix even the smallest fix, the smallest feature, and require you to update your whole server. And when you update your whole server, you get downtime, which your users doesn't like that much and don't appreciate. And combined with the slow startup time, yes, you are muted. Combined with the slow startup time, it means that your clients suffer more and more as your code base grows. And finally, there's the reliability issue. When something breaks inside your monolith, the whole server goes down. And if your memory ran out of memory or disk space or anything, then your users start to notice. Now, all of those are reasons why companies start to move into microservice architecture. But that's easily said and done. And we usually have code bases that have been developed throughout many years. And those code bases are required. They need to run because you have users and you have customers and you need to continue to give them what they want. You need to continue giving them the service or the application or the functionality they love and care about. So you can't just immediately stop working with your monolith. And so you need to think what to do. And the good news is that with the cloud, certain things become easier. But before that, let's talk about our options. Let's say I have an ASP.NET application running on premises on IaaS, probably an MVC application that was created a few years ago using an older version of the .NET frameworks running on Windows Server. And what can we do with it? We have a few paths that we can take. The first one, the rehost path, essentially means lift and shift. Lift and shift means that I take whatever I have on premises and move it to the cloud, basically as it is, without making too many changes. And so we want to take whatever we have and with as little change as possible and move it either to a virtual machine on EC2, or we can go the extra mile and host it inside AWS Elastic Beanstalk, which enable us to have to copy the environment and then redeploy it in multiple places, scale it automatically, have blue-green deployments, and some additional functionality that virtual machine require a little more effort to make. But essentially, our applications remains exactly the same. The second option we have is to somehow containerize our application along with its environment and host it inside a Docker image. And then we can use the benefits of having a Docker image, which means I can use an orchestration framework such as ECS, Amazon Elastic Container Service, or Kubernetes on EKS. And I gain quite a lot by taking a little more, doing a bit more, and containerizing my application. It's not always as easy as said as done, because I need to know things about my application, which with all the applications is hard to know everything. The configuration, the required environment, which ports to open, do I need to connect to a database? And all those things, all this knowledge that was created over time about how to run my application. But once I do know that, I can put my application inside a Docker image. And then the next option is to refactor completely, move to .NET Core in this case. And then I can use Linux containers, I can use microservices built on top of ASP.NET Core, or completely take my code and rehost it and refactor it to work inside the Lambda function, and which require me to take the logic from within my code and just take it out and put it inside the Lambda function and break my architecture and re-architect the whole application in a serverless manner. All of those are valid options, but obviously they are not equal. In fact, the more changes I need to make, the more I'll gain. If I go all the way to Linux container, I'll gain quite a lot. I'll get quickly starting Linux containers. I'll get a microservice application, but I need to invest some time and effort upfront to get them. While if I stay with IaaS on top of a virtual machine, I don't really need to change a lot, and I can get up and running pretty quickly. But it's not just change. The change doesn't always equal effort, because there's additional efforts involved. For example, in order to make sure that my container stays up and running, I need to invest less operational effort than running on a virtual machine. On a virtual machine, my people need to make sure those virtual machines are auto-scaled and make sure that they're up and running and that my application is healthy. And some of that I get automatically out of a Docker orchestration framework or in a Lambda function. So it's not that the more I change, the more effort I need to put in or invest, but it does seem that way, at least in the beginning, because it does require me to go into a code base that was created a while ago, and it's not always easy. It's not always, usually the requirements are unclear. It's not simple to understand what I need to use and how to use it, how to host my application. And that's the reason we are talking about the tools that will help us make the bigger change with less effort. And the first tool I want to talk about is Up2Container. Now, Up2Container, it's a command line tool that you can run on your existing website, on your existing IIS application, and it will automatically analyze and then containerize your code. And you can even deploy it. And it works in a very nice way, and it helps you discover what you need in order to host your existing application inside the Docker image. And the way it works is that if I have a website running on IIS and I want to host it, the first thing I'll do is run an inventory command, which will give me a list of all the application running on that website. All of the website on IIS, sorry, not the website, all of the website or applications, I'll get a nice list, and I can run all of those commands either from on the same machine, or if I prefer from a different machine, because we saw some cases in which there's no development stage environment which I can play with, and I don't want to install Docker and app to container and then run them on a machine that could potentially be used by other teams or users. So I can run it from a different machine, but in the end, it's the same result. I'll get a list of all the existing applications, and then I can choose one of them and analyze it. And I will get a report out of app to container, which tells me the type of the application, .NET or Java in this case, the operating system, and other parameters such as open ports, connection string, and interesting configuration options, other services used. And all of those will help me understand what I need and whether or not that process has found everything, and I can tweak it by adding more information or updating the found information before progressing to the next step, in which I'll extract the application, essentially copy it somewhere to another folder, and then containerize it using Docker. Afterwards, I'll create the deployment artifacts, and then I'll get a few nice things I can use. I'll get a Docker image. The Docker image now can be used on any Docker orchestration framework or just run using the Docker command line tool. I'll get the tasks definition or the pod definition, depending if I want to use ECS or EKS, that describe not only the task or whatever will run my Docker image, but also the actual cluster with the definition of running that workload. And finally, I'll get additional CloudFormation templates, and that depends on what I need. I can create a complete infrastructure, the complete AWS infrastructure that we'll see next, just from this CloudFormation template, or I can choose to use my existing infrastructure and host my Docker cluster inside an existing infrastructure, and then I'll get the details on how to do that inside those CloudFormation templates. And then I can take all those three and deploy. And when I deploy, the Docker image will be put inside the container repository, Amazon ECR. And then my cluster will be deployed either to Amazon ECS or Amazon Elastic Kubernetes Service. And it will be up and running with exactly what I want. And I can test my application and see that I got the functionality I need. So essentially, this is what gets deployed. I'll get access from the internet with application load balancer, with NAT gateways, and all of those just for this part in the middle where my old IIS application just ran. And I can use that as if it was running on top of IIS on premises. Same functionality, same behavior. But I also get additional things. In my case, I've also added the database. It can be in RDS or any different place. What I tend to do is either connect the old application to the new database or just change the connection string before deployment. And then I get the full stack running. On top of that, I also get versioning through the container registry. I can always know which version I'm running of my Docker image. And I can use additional AWS services such as Secret Manager and Parameter Store in order to keep all my information in a secure and manageable way. Because once I get this infrastructure running, I can copy it for additional environments, staging, production, pre-production, depending on what you need. And then this is a very good solution to get me from on-premises, easily deployable to the cloud. And this is a good start because there's still some things I need to tweak. I have here Windows containers, which they are essentially containers. In this case, they run on top of virtual machines, EC2 machines, but they can also run an ECS on Fargate in a serverless manner if I don't want to manage machines. But I still have some issues with this solution because this solution is still problematic as far as startup times. It takes a while to start Windows containers. They are not as quick. And also, I haven't solved the problem of my development efforts. I'm still handling a monolith here. It's easily scalable, easily deployable, but I still, when I need to develop new functionality, there's a lot of code I need to read and understand in order to use it. And in this point, I want to break this monolith into individual microservices. But before I can do that, I need to make sure that my application stays up and running throughout the process. So the first order of business is to have a continuous integration and continuous deployment pipeline. Essentially, what I want is that with each new change to my code, that change will be tested in order to ensure that I haven't broken anything, and then deployed to my testing or staging environment. And I do that in order to continuously build. I don't want my development teams or my operation teams spending time in deploying application all the time. I want it to be streamlined. I want it to be quick. I want when a new change is pushed to my code base, to my repository, automatically the application gets built. I get a new Docker image. It is deployed automatically to the cloud. And I want to run tests as well. Now, in this point, I need to add those. I need to add probably unit test, integration test, end-to-end test, automatic tests. And I need to do that in order to make sure that as I keep on pushing new and new builds, nothing gets broken. Everything continues to function as expected. And once that happened, I needed to be deployed to my cluster and make sure that I'm running the latest code. There's no point in having code on the developer machine if it at some point doesn't get to a place where it's merged automatically and deployed with the rest of the changes. And I want to have this pipeline running all the time. As new changes come in, they are being tested and then deployed. And the good news is that I can use After Container to do that as well. Because we talked about the different stages. So we have Containerize, all of the stages that I talked about, which create the base image and then create the deployment artifact, move to the ECR, where the Docker images reside, and then deploy it to ECS. But there are more things that happen during this process. When I create the base image, After Container will also create two files, a Docker file and Docker file update, which I can use. I can take them as is, or I can use them in order to recreate the image over and over again. Just point it to a different version of your application, and you get a new Docker image with a new version, with a new code. When I create the deployment artifact, a file called pipeline.json will be created, where I can either use it as is or edit it in order to then run a command to generate a pipeline on top of AWS using AWS code commit and code build in order to rebuild my Docker image every new change, and then deploy the updated image to ECR, then rebuild my CloudFormation template that describe my infrastructure and redeploy that to ECS in order to get the latest version of my Docker image. So I can build that pipeline automatically. But if I use another tool, Well, it depends. If I'm using Jenkins, I can build the same pipeline automatically with up to container for Jenkins. But for other tools, I can take those building blocks. I can take the Docker file and I can create my own build pipeline on top of my tool of choice and have the same process in place. Add tests and I have a continuous integration, continuous deployment pipeline that I can use from now on in order to redeploy my application over and over again with each new change. And without that, I won't be able to progress to the next level. So this stage is important. But once I have that, now when I fix bugs or add features to my existing monolith, those changes will be deployed automatically. They will probably be deployed to a staging or test environment. And once I'm happy with those changes, I can propagate them to my production environments, knowing that the same container with the same environment, with the same code that I just tested will run exactly the same in my production workloads. And this is still a good start because the next order of business is to break things into microservices, continue to the next step. So how do I do that? First of all, I need to modernize my code base. If I'm using an old enough application, I need to move from .NET Framework to .NET Core. I want to do that in order to be able to use Linux containers, which tend to be smaller in size, smaller footprint, and run faster. And I want to use the latest and greatest development tools, the latest IDE, the latest Visual Studio, Visual Studio Code. And I want to be able to use the latest libraries as well, and the latest code construct that we just got with .NET 6. So I want to change my code. I want to update it. I want also to change my architecture. I want to move from a bigger monolith that I'm having problem to develop and maintain to microservices in order to be able to scale those microservices individually and even deploy them individually. If I just change something in my inventory service, there's no point in updating all of my code and get a long downtime for everything. I also want the ability to hot swap my services as they're being updated. Once I move into microservices, I'll get the well-defined boundaries that will enable my developers to quickly fix and add features because everything is well-defined and not all the code sits in the same place. Bugs becomes easier to solve, new features are easier to develop. And this decoupling will enable me to increase the size of my team as well, because now each service is individually deployed and individually developed as well. So I can break the work throughout many teams instead of one monolith where everybody changes everything. It makes my life easier, especially from when I get to a certain size in my code and where it becomes a mess. Breaking into microservices is a good idea. But there's a third thing. I want to harness the infrastructure provided by the cloud. I want to move to containers and serverless applications. I want to do that because I want to reduce operations overhead. I don't want to manage always versions or open imports. I want to focus on my differentiating value. I want to focus on the value I give to my customers, the business logic. I don't care about the infrastructure itself. And as I move to newer and newer code, I can use more infrastructure to solve problems I used people to solve before. I need the operation overhead decreases, and so I can even create more and more application, more value to my customers at this point. So how can I do that? It's hard. It's not an easy thing to take a big monolith that probably not everybody remembers exactly what it does or the exact functionality or the decision made 3 years ago. And I need to be able to keep that functionality working no matter what, because I do have customers that need to continue to use my application. And I need to avoid lengthy downtimes. I can't afford to have my application down, depending on your business, an hour, 5 minutes a day. That's not acceptable usually by our customers. Now, another problem, once I get to a big enough size of code, is that it's hard to find the service boundaries. When looking at a big chunk of code and starting to think about which method and which class, or which part of my code should reside in a different service, it's hard to see that when looking in a big enough code base. Some of it requires a lot of manual rewriting. Even just moving between .NET versions might require you to change a few of your dependencies, a few of your libraries, which can become very painful. So you don't want to do that. And we don't want to increase the operation overhead. No, we want to keep our teams lean and effective. And some organizations, when they look at those options, say, okay, we'll keep the old legacy code up and running, and we'll start developing from scratch or nearly from scratch a new microservice-based architecture. And we'll have those side by side until a certain point in which we'll phase out the old application, phase in the new application. That's a very problematic thing to do, because it takes quite a while. And at the time I'm creating the new code, the latest and greatest, the old one doesn't sit still. There are bugs and features that my customers need. So it keeps on advancing. And now the new code needs to add more and more features and functionality and bug fixes on a completely different code base. And it's hard to maintain those two side by side. And it's hard to find the point in which we say, okay, now let's take away the old application that my customers are using and put the new one that they haven't used before, completely new, no idea what state it is in a way, and replace it. That's a very hard thing to do. And I need to maintain all those two side by side, which is also not impossible, but very hard and very painful thing to do. So I don't want to do that. I want somehow to incrementally move code from my existing monolith into new microservices running in different technology. So how do I do that? If you have been listening today, you might have seen this. The strangler fig pattern, which was discovered/invented, talks about taking a legacy application that my users, my clients are using, and then either use a facade or use the actual legacy application as your facade to call the new services. And now what will happen is that whenever I have a new feature to develop or a bug to fix, I'll write it in a new microservice, or take the code that is related to that new feature and put it in new microservice and make the legacy application call it internally without my customers noticing or knowing. They don't really need to care about that. And they can either call the legacy application or call a facade. It can be a load balancer. It can be part of your code. And that code will orchestrate running, calling other services, calling your legacy application, calling your new services, or calling the legacy application that will call your new services. And then you can start slowly breaking functionality outside of your legacy application into your new services. And once you do that, at some point, your legacy application will shrink to a point in which you can decide whether or not you want to keep the existing functionality or just phase it out and replace it completely. In the beginning, you want to keep functionality inside your legacy application, operational functionality that you might need, like authentication, authorization, user management, or maybe your main big business logic, the big part that works throughout other different pieces of logic, and that's fine. But at some point, those will migrate to new services, and then you'll be able to break things and modernize them. Now, it's not easy, and it will require us first to understand my existing code, and then find the places where I can take parts of my existing code and take them out and put them in new microservices. And there are tools that will help you do that as well. The first tool is Porting Assistant for .NET. Now, I know there's already been a session on Porting Assistant for .NET, so I won't rehash it. But basically what it does, it will take your source code and it will generate an assessment report telling you how much of your code can be automatically ported and the effort it will take to port the rest of your code. And you can prioritize what pieces of code is easier and what is harder to migrate outside of your code base. And you can identify incompatible APIs and packages and find for you automatically a known replacement. Now, once you're happy with it, you can just click a button and you will have a new .NET Core solution with the new code after conversion that you can use or fix and then use. And Porting Assistant can save you a lot of time modernizing a lot of the manual labor, which is both very technical and it doesn't really add value to your customers. And you can do that automatically using Porting Assistant. The second tool that will help us is AWS Microservices Extractor for .NET. And there's a talk about that topic specifically later this day. But to roughly summarize that, Microservice Extractor for .NET is another tool. It's also freely available. We can use those two together. In fact, Porting Assistant is used within Microservice Extractor for .NET. But the first thing I'll get is a map that shows me the different parts of my application. It will map your big application, your source code, into different objects, different classes, and the relationship between them, which part of your system calls which part. It enables you to mark those parts together in order to then extract them. You can automatically extract them into different projects, and Microservice Extractor will help you both identify the places where you can break your system into different parts and then extract it into different projects, replacing method calls with HTTP calls, essentially creating the existing old application and the new services we just discovered. And I can take the code as it is or take the parts I do care about and put them inside my own projects. But those two tools together can save you a lot of manual labor, a lot of time, by helping you get started on your refactoring efforts. Let's just see those in a minute. Here we have, this is the Microservices Extractor for .NET. Now in here, I have a bunch of applications I've already analyzed beforehand because it takes a while. And then I'll get onboarding success and I can click on my application, see the details, but then look at the dependency graph. Now here, immediately, without even knowing what the application is about, I can see different groups. Those groups, some of them at least, will map into individual microservices. And then I can examine specific nodes by clicking on them, for example here, and see who is being called by this specific part and who this part is being called by someone else. Now, if, for example, I click on something I prepared beforehand, here we have a geolocation service, which is a good hint about something that can be a service. I can see that it is being called by a single controller, which is a good candidate because I have a controller, it's called service. It can call it in process, or in my case, I want to call it in a different process. And then I can see the responsibilities. I can see that it's using lat long, which is an object, but I can see that object has been used by a bunch of other services, so it's not a good candidate to take out. But there's a string extension that is only being used by this service, and as well as location info. So I can, using the microservice extractor, I can mark all those in the single group, saying, I think those belong together, and I can increase or decrease the size of that group. And then I can see the node summary, which I need, which goes who, and press extract group. Now, once I do that, it will create the extraction metadata. And we can use either remote method invocation or local method invocation. But, and obviously it takes a while. And on top of that, if we go back here to the specific group, I can see the portable analysis, the compatibility, whether or not those things are in fact portable. And here I can see they are all compatible. And all the libraries they are using are compatible. And this is in fact a portability assistant report. And which means that I can automatically extract this part of my code outside of my main monolith automatically. Once I press extract, I'll get two projects, one for the existing legacy code, existing monolith, and one for the new service. And now I can really start to work and change things there. So that's how I can use those two in order to create this architecture. So we have everything from before, but now I've also added another cluster to run my new microservices running on .NET Core. It can be in the same cluster or in another cluster, highly dependent on the specific technology I'm using. But what I really need is the ability to call the new services, both from my load balancer, at least at some point, and from my legacy application. So they need to know one another. We can do that using Cloud Map and App Mesh in ECS, so that one service can call another service directly. And once I deploy that, I need to deploy a continuous integration pipeline for the new services, each new services as well. In order for now, my developers will be able to take code out of the legacy application, create a new service, deploy both automatically using my CI/CD pipeline. And as far as my clients, as far as my users calling from the outside world, everything continue to function exactly the same way. And I can do that easily using the infrastructure that I get inside AWS, inside the cloud. Is that the end? No. Now I need to think about the next step. Once I have this in place and my development teams started breaking microservices outside of my initial legacy monolith, now I can think about the next step. I can convert some of the code, either manually or using portability as an assistant, into Lambda functions. Specifically things that are shortly lived, less than 15 minutes running, and have a burstable kind of workload, something that you get a bunch of users and then nothing, and you can connect them either directly to my load balancer using a different API gateway, or even use a queue or another AWS service in order to break the functionality into Lambda functions as well. I can use queues for asynchronous operations, because right now we only saw synchronous operation. I will create a HTTP call to my legacy application. It will call a new service. Everything here is asynchronous, but as I start to break things into different functionalities, I see there's some workloads that need to run in the background and some that need to run to return immediately to my user. The things that need to run in the background, I can use queues in order to queue a message or request and then take it in my service or in my Lambda function, perform it in the background without wasting my user time. And I can also start to think about my data, because right now probably you have one application with one database or several databases. And now I need to think which service has which data and break the data between the microservices, because ideally I only want one service to see one table. I don't want the table to be shared between different services, and I want to see which data belong to which functionality. And once I do that, I have a continuously refactored monolith. So to summarize it, we'll start by containerizing the existing applications in app2 container and get Windows-based containers that I can easily deploy to the cloud. I'll host them in EKS, one of the container orchestration frameworks. And then I can start working on my code base. Start using Ported Assistant and Microservice Extractor to break pieces out of my monolith into different microservices, into Lambda functions. Use .NET Core, which is either called from the legacy code or directly from the outside world. And all of this is possible if I have a continuous integration pipeline to continuously check, test, and then push the changes as my code changes. And that will enable me a very streamlined, a very fast development pace that will help me modernize existing monolith in the cloud as I move it from my premises, from my data center to AWS. Thank you. I'll be happy to answer any questions if you have any. You can write them down in the chat.